There's been a lot of talk recently about vibe coding. And first, let's define what vibe coding really means and also how vibe coding has already existed for quite some time with Python. So, first up, the concept of vibe coding is an interesting concept that really means that you're using large language models to do the majority of development and you get something to work and then you put it into production. Now, there are some interesting components of this. And in fact, prototyping is a strategy that's been used for decades. But let's first, before we get into vibe coding, let's talk about vibe coding 1.0, which is Python. So I've had experience with Python for several decades, and I've seen in practice what happens with vibe coding. And I'm going to talk about what potentially is the problem with vibe coding and how you could solve it. So first up, the idea with Python and why people liked it is that traditional programming, C and Java, were very complex. So C is obviously a lot more complex than Java. And so we see this evolution with software languages where they were very, very low level assembly. Then we went to C, then we went to Java. And this trend is that you want to keep making things more productive, make it easier for people to develop solutions. But in Python in particular, we went to the level where it's so readable and so easy to use that it hides a lot of the true complexity that's necessary complexity to build production systems. So that's part of the problem. The second part of the problem is in terms of real world production systems, where this is where I spent the majority of my career. I wrote 6 books on this. The idea here is that when you're building things for production, you don't really care about the speed of the development. That's not the problem you're solving, is how much code you can write. In fact, I've worked in environments where unfortunately the faster someone wrote code, the faster they would create bugs. And you're essentially spewing bad code all over a company, and eventually the bill will come due, and the bill could be so substantial that could bankrupt your company. Let's talk though a little bit about what this means in terms of the speed versus the system. The idea in a real world production environment is that you want to continuously improve the system, not build it once. And the best way I would describe this analogy is if you're building a children's playground or you're building a house or you're building a bridge, you're going to design it very heavily up front. You're going to build it once, and then you'll do very minor maintenance afterwards because it is a fixed design. And if you look at that kind of engineering, the concept of vibe coding is kind of appealing, right? It's like, hey, look, we don't ever have to make a change to the system, so let's vibe code. The problem is that that is not how software systems work. Software systems are not a children's playground. They're not a house. They're not a bridge. They're more organic. So they have a lot more in common with a plant or a tree, or a fig tree in your yard. What happens with a fig tree? So you dig a plot of hole in the ground, right? You build out some dirt. You maybe put some fertilizer in there. You put the fig tree inside, you make a hole for the water, you put some irrigation systems in there, you maybe put a net over it, etc. You could say, okay, I'm done. Well, that's not how it works, because the fig tree is going to require constant maintenance. You have to check in on it. Hey, does the fig tree have bugs? Does it get enough water? Is there a problem with too much sun, too little sun? What are there effects of a windstorm on it that broke the branches? You have all of these different problems that happen with an organic system because it has to be maintained and nurtured. Similarly, in the real world, any kind of platform, production system, mobile app, it is an organic system that has to be maintained. So that's the real problem in software engineering, is maintaining an organic system. Now let's take another example of how this would work in the real world. If you go to a grocery store and you look at the self-checkout, this is a really good example of more of an organic process than a fixed process. It's true if you buy very simple things like, I don't know, a bag of candy or something, or a toothbrush, self-checkout could work pretty well. The problem is that in the real world, people don't just buy one item, they buy multiple items, and often let's say it's produce, or it's like a new packaged item, or it's an expensive bottle of wine, or some kind of weird artifact, is that you can't get through the checkout line 100% by yourself. You need a human to, kind of coach you through it, unblock you. And so we have human in the loop. So it's much more of an example of an organic system, just like the fig tree. So that's the real problem with automation, is that you always need the human in the loop. Now, if we take a look at Python, what are some of the things that it did when it first came out? Let's say late 90s is when you really started to see Python come into its heyday. And what are some of the things that were said about Python? Well, first of all, that developers are more important than the CPU time. And, you could make an argument for that. But also, there was an argument that the safety was less important. Like, we don't need types, although Python has reversed on that. Also, we don't need true threads. Also, Python has reversed on that. And then also, potentially, we don't even care about a compiler. And that also potentially could be a real downside of a scripting language. So you've traded the speed which you can write the code. And the reason you're doing this is you think that that's the real problem to be solved, when in fact, it might help you solve the real problem, but that's not the real problem to solve. Again, the problem to solve is continuous improvement of a system. So if you could develop features faster and use CI/CD, look at the metrics of the system, look at the bug reports, and then develop fixes to those bug reports and the data science of the deployed system, then maybe you could make the case that Python potentially could be an advantage, because you can not only write the code quicker, but you can respond to the bugs quicker and put that code into production. So continuous improvement, or Kaizen, is the essence of the process that has been validated for building production systems. So this is the real problem to be solved. So if we go back to vibe coding here for a second, the problem isn't, and it's never been, about how quick you can create software. The problem is how can you maintain and continuously improve a system? And here's where there's some danger with the vibe coding, just like there was danger with Python. With Python, you don't have types, you don't have a compiler, you don't have true threads, you have mutable variables, right? Many languages have made variables immutable by default. You have don't have public and private methods. You have all this kind of freedom to create code, but it starts to come to bite you. And I've seen it in production where people are deploying code that is not executable, right? Python doesn't have a compiler, so how would you know? Likewise, there's dead code paths, or there's typing issues, or there's all kinds of really simple problems that could be solved with a compiler or a modern compiled language that Python just lets you put into production. So if the goal is to just build code, then sure, why don't you just write a bunch of bad code? But if the goal is to maintain the system, every time you write new Python code, you're creating a problem. Likewise, if we go to the vibe coding, the problem is not to develop code as quickly as possible. The problem is, how do I solve a real world production system and maintain it over time? So I would say that some of the components of vibe coding make sense to me, right? So let's use more automation. We can help, write code that's boilerplate code, or help, figure out APIs and libraries and stuff like that. And also potentially start to get away from these scripting languages and get more towards languages like Rust, which have very strict design features that make it better in terms of maintaining the system in production. So I would say, if you look at vibe coding, the parts that make sense to me would be, hey, let's go ahead and let's improve like how much code we can write, with the goal in mind that we're going to build a system that we can continuously improve. But again, that's very different and subtle detail. And so what does that mean is that, sure, why not use tools that can help you write a command line tool or microservice or whatever? But the goal again is to think about the entire system. How do I make sure that I'm able to maintain the system, that I'm not putting bugs into production? How do I make sure that other people on my team know what the code does? So I do think there's a lot of promise for code that is generated from large language models, but the problem isn't, again, writing the code. The problem is maintaining the system. So that's really the trick, is how can you use these tools with the goal in mind to maintain the system? So if we go back to the playground, the children's playground versus the fig tree, sure, if you could press a button and a children's playground would appear, like, I don't know, a prefabricated playground, great. But that's not the problem you're solving with a fig tree. You can't print a button and a fig tree appears that is going to grow over the next 20 years and have awesome figs that never have any problems. You're actually in it for the long haul, where you have to look at that fig tree, make sure it's doing what it needs to do, make sure that it survives, etc. So likewise, with any system that is using generative AI, I think it's better to look at a big, long picture of what it is you're trying to do. You're trying to build a system that you can maintain for the next 10 years. And if those tools will help you do that, then great, use those tools. And I do think that they're very useful. I use them myself, but I would say this is maybe a reason to change languages, change from Ruby or Python or Node, and change to languages like Rust that have very strong safety features, because it's less likely the code that you put into production will have bugs. It doesn't mean it's 100% guarantee. There is no 100% guarantees, but if you're going to have tools generate artifacts for you, why, if the goal is to maintain the system, why wouldn't you use the strictest language possible? So I think it's really an interesting time to think about, these ideas people are bringing up about, hey, let's do this, let's do this. But if we look at the history of software systems for the last several decades, the real problem isn't writing code, it's maintaining code. Second, why wouldn't you build things that are the most secure as possible by using the best tools as possible? And then maybe finally, never has the problem been in looking at systems that you build them once and then you never touch them again. It's really about maintaining systems for the long haul. So when you're getting advice from someone, you should be getting advice for people who are practitioners at maintaining systems, not necessarily a dilettante. If you're a dilettante with software engineering, maybe you understand Python and you think because you wrote some Python scripts that you understand production systems. That's not the case. The people that you should be getting advice from are people that have been maintaining large-scale systems for decades, people who are real practitioners. And everyone that I've talked to mimics the opinion that I have, which is that the real problem is maintaining the system in production. So very interesting thought experiment to dive into this concept of vibe coding. And I think the takeaway for many people is that Python is vibe coding. It's just a different kind of vibe coding. And that if you look at some of the real problems that have happened from, web frameworks like Django or Conda, a lot of this kind of vibe coding stuff is pushing the technical complexity down the road until eventually there's an existential threat to your entire company because the code is so bad. And I've seen it. I've seen Python code so bad that it had essentially the core components were going to collapse the company many times, not just once, multiple times over very different industries. And a lot of it is just the nature of this very fragile kind of code. And so I think the takeaway is try these new tools, but put the mindset in play where the goal is to maintain a system over time, not just generate code.